The first few minutes of this video are dedicated to giving you an introduction to R. So if you've literally never opened before or you feel like you've got a really bad grasp on what's going on, might want to stick around. Otherwise, you can probably skip ahead. So I'm going to show you from the beginning what happens when you open R for the very first time. When you open R, you see what's called the console. It's a giant pane, a giant window that just has what's going to be the output of any given code you put in. On the right side of the screen, you have the environment and you have plots, little outputs that are going to show you what some possible outputs or inputs that we'll put in and play with later. For now, we want to create a new R script. So we're going to go to File, then New, and select New R script. That's going to create a window above the console, and that's where you're going to put in all the code that you're going to do for your homework and any of the projects that you work on. When we run lines in the script, they will appear down below in the console. So I'll show you some examples. I'll do something like simple as 3 plus 7 or 12 times 4. And when I do that, I make sure I click the run button in the upper right. When you click run, that can be a little tedious. So there's a couple commands you can use to make sure a line runs like that. You can either use Control Enter if you're on a PC, or you can use Command Enter if you're on a Mac. And that just makes things go a lot smoother rather than moving your cursor up to click run every single time you want to run a line. At this point, all you've seen me do is 3 plus 7 and 12 times 4, but R is so much more than a glorified calculator. It can do some fancy things for us, and in order to do that, we need to install some packages. So in our R script, we're going to go to the first line and type install.packages. Notice that as I begin to type the word install, a little menu pops up to the right, allowing me to click install packages to autofill the rest of it for us. When we do that, I'm going to put in quotes and in the parentheses dplyr, D-P-L-Y-R. That's a package we're going to be using when we want to use the pipe command. We'll talk more about that later. And we also want to install the package ggplot2. Install.packages, open parentheses, quote, ggplot2, close quote, close parentheses. We're going to run both of those lines one at a time, and it's going to show some stuff below the console. That's fine. The console is just there showing you that, hey, we're just going to install a bunch of these packages. Don't worry, we'll be done in a moment. Usually red in a console is a bad thing, but this red is just telling you, hey, listen, we're going to be installing these packages that you told us to install. Give us a minute. Once installed, the ggplot2 and dplyr packages never need to be installed again. That is the first and last time you'll ever have to install those packages. However, every time we start R or start a new R script, we need to include those libraries. We do that by typing library ggplot2 and library dplyr as our first two lines and making sure we run them. Note, I don't need any quotation marks around the names of the libraries this time inside the library function. And note the comment that I've put to the right of each library. I've said that the ggplot2 library allows us to make some fancy plots, and I've also said that the dplyr library allows us to use the pipe command, which is denoted by this % greater than symbol %. I'm going to get into an example of what this piping function does right now. Let's create a vector. A vector is just a list of numbers, and it's the basic building block of RStudio. The first thing you have to do is give your vector a name. So I say x equals, but you could choose to use any other variable you want. You could use x, you could use y, you can use banana, you could use refrigerator. I don't care what you put on the left-hand side of your equal sign, but I choose x for simplicity's sake. So my vector's name is x, and the way I create my vector is say c, open parentheses, and list the numbers that I want in my vector. Here, I'm going to put the numbers 3, 4, 5, and 6. Closing parentheses on the end, I'm then going to run this line, and you'll notice that x will appear in the environment panel on the right. It's just saying that x is now a vector that it recognizes, and you can do all sorts of statistical manipulation to that vector whenever you'd like. For instance, I could find the mean of my newly created vector x by typing mean open parentheses x and then running that line. And sure enough, the average value of 3, 4, 5, and 6 is 4.5, which is displayed in the console below. But how does the piping function tie into this? Well, the piping function is just an alternate way of expressing the same thing we did above. Here's how this piping function works. We're going to put the function we wish to apply on the right and the data set or the vector that we wish to apply it to on the left. So I'm going to put mean on the right because that is what I want to apply, and I want to apply it to the vector that I created called x. Another way to read this is I say, I want you to take x and pipe it into the function mean. Once we run this line, we sure enough get the same result of 4.5. One last thing is that we sometimes put the function that we wish to apply via pipe down beneath the pipe in the next line. Do you have to do this? No, the result will be the same, but for aesthetics purposes, we tend to put the function we wish to pipe down below. Now let's import a data set. We do this by going to the upper right corner of our RStudio, right above the environment pane, and clicking the import data set. When we click import data set, we see a list of options, and because we're going to be mostly using CSV files this semester, we're going to click from text, which says base in parentheses next to it. So we'll click that option, and we're going to go find the file that we downloaded that's named whatever it is for our particular project. In this case, I'm finding plays underscore top 50, selecting that, and then notice I get a new window that appears that tells me how Before we import the data, it's important to check the Yes button underneath the word headings. This is because, as you can see in the preview of our CSV, one of the rows is actually the band names that we would rather have as the headers for our column. So once we check the Yes button, those names of the bands move up into the headers of our columns, and then we click Import. Once we do so, the table of all the data fills up where we previously had the R script showing us a bunch of ones and zeros, whether or not we liked a band or didn't like a band. But we want to start going back to our R script so we can do some work. So we're going to click the R script tab on the upper left, and then we can get started. Suppose we wanted to count the number of people who listen to the bands Muse and AC/DC in our Plays Top 50 dataset. Well, that would be a tedious process, given that, as you can see in the environment, the Plays Top 50 dataset has 15,000 different observations. That is to say, 15,000 people were surveyed for this project. Well, I don't want to count 15,000 observations, so that's where the function xtabs comes into play. Xtabs will create a table for us that counts the number of people who listen to both Muse and AC/DC. So xtabs first requires a tilde, which is this little squiggly inside the parentheses, followed by the bands we wish to count in our Plays Top 50 dataset. So we're going to put Muse plus AC.dc, and then after that we need to tell it what dataset these bands are coming from. So we put a comma followed by data equals Plays Top 50. We close that parentheses and then we run this line. And what's created is this table of 4 values. This table of 4 values shows us who listens to both AC/DC and Muse, those who listen to AC/DC but not Muse, those who listen to Muse but not AC/DC, and those who listen to neither Muse nor AC/DC. And you can tell based on where you see zeros and ones as column headers or row headers along the sides of the table. Note that in the upper left corner, I see a 0 above the 12,476 and a 0 to the left. That means those are the number of people who listen to neither AC/DC or Muse. But we see to the right of that, 813 people listening to AC/DC but not listening to Muse. Now that we have the raw numbers of people who listen to Muse and AC/DC, we want to convert those numbers to percentages. That's where the function prop.table comes into play. We're going to call prop.table around our xtabs function so as to convert all those raw numbers to percentages. And actually, bear in mind that when you create this prop table, these aren't actually percentages, they're proportions. So 0.83 isn't a percentage until we multiply by 100 and call it 83%. Now, it might be easier to work with decimals because, after all, when we think of probabilities, those are always numbers between 0 and 1. But just bear in mind that prop.table converts to proportions, hence the name prop.table. And the first upper left value we see is that 83% of people neither listen to Muse nor AC/DC. Notice that instead of putting xtabs inside my prop table function, I could have instead used the piping command. Here, I decided to take xtabs and pipe it into prop.table. And when I run this set of lines, I get the exact same answer as when I put xtabs inside my prop table. Now, does it matter which one you do? Shouldn't matter one way or the other. You can choose this method or you can choose this method, but you will get the same result. There's one more thing we need to do, or a couple more things we need to do. The first thing we're going to do is round. So the rounding function is just like prop table, just another function we're going to apply. Here I can put round outside my prop table and call it on the entire table, making sure I put .3 to signify how many decimal places I'd like to round it to. If you're going to pipe instead, once more call the pipe command in front of the prop table and tell it you want to round that table to 3 decimal places, like so. So the prop table we've created is what's called a joint probability distribution because it tells us the probability of 2 events occurring at the same time. For instance, the probability of both liking Muse and AC/DC is found on the table in the bottom right corner. That's 0.007. But what if I want to find some sort of conditional probability? That is to say, what if I want to find the probability someone listens to Muse given that they already listen to AC/DC? Well, this requires an optional argument inside prop.table. So inside prop.table, we already have our xtabs. That doesn't change. But we need this optional argument over here on the right. We put comma, and we're going to introduce margin equals. Now, depending on the variable you want to condition on, you will either say margin 1 or margin 2. Because Muse was the first band listed in our xtabs, margin equals 1 will condition on Muse. Because this probability statement here conditions on AC/DC, I'm going to say margin equals 2. Note that I can do the same exact thing by piping margin equals 2 inside my prop table command in the line where you see prop table, and you'll get the same result. Let's back up a bit and answer a different question. Are listening to Muse and AC/DC independent events? Well, in order to do this, we're going to revisit our original joint distribution table. And in order to do that, I'm going to delete the margin equals 2 optional command from my prop table. So I'm going to go ahead and delete margin equals 2, rerun the line so that I have my original unconditional probability table. Now, what if Muse and AC/DC are independent? Well, that would mean probability of Muse times probability of AC/DC are an exact match with the joint probability μ's and AC/DC. We found this probability earlier in this video. We found that to be the bottom right corner of listening to μ's and AC/DC. We found that value to be 0.007. But what about the probability of m's and probability of AC/DC? What are those individual probabilities, and are they on the table? Well, not quite. In order to figure out the probability of listening to m's, or the probability of listening to AC/DC, we'd have to add the column corresponding to AC/DC, corresponding to listening to AC/DC, or adding the values in the row corresponding to listening to m's. Alternatively, we can use a function called add margins. Add margins just adds up all the columns and rows in our table and just puts them to the side of the table, just doing the addition for us. Note that when I call the add margins command on my prop table, I find that the probability of listening to m's is 0.114, while the probability of listening to AC/DC is 0.061. Now I'm going to use a calculator to multiply these two things together. No matter how close I get to 0.007, unless it's an exact match, they're not independent. So we're going to go 0.114 times 0.061. I get 0.00695. And yes, it is very close. But despite this, it is not a perfect match. And because of that, these two events are not independent. Well, that does it for this short R introduction video. Be on the lookout for more videos from us, but more importantly, if you want to join our weekly Sunday sessions hosted by me, follow the link here or down in the description below, and I'll see you guys on Sunday.